Good evening. My name is Sebastian, and together with Arne, we are basically here for the week in Santa Clara at ZenCon, one of the biggest PHP conferences. And when Noah found out that we are close by, he asked us to present here tonight, which is something that we really like to do, get in touch with meetups and user groups wherever we are to share our experience, because we just like to hang out and present and talk a lot. Not really. So agility and quality. So my name is Sebastian, and I already told this in a really long version over pizza before while we were waiting. About 13 years ago, I started doing things with PHP, and a couple of months later, I started doing things to PHP. Back then, it was a really slippery slope, getting involved in the project. So for me, it started with working on the German manual, then I worked on the English manual, then I found bugs in PHP and figured out how to fix those bugs. And by the time I had figured out how to fix bugs, the planning started for PHP 5, and I got involved in things like the object model, the reflection API, exception handling, and all that kind of stuff. And around that time, I got involved, or I came across the concept of unit testing. I wanted to have that in PHP. There was nothing that actually worked. So I started PHP Unit. That was like 11 years ago now. Has been growing ever since. Nowadays, people actually show up when I present on PHP Unit. Back when I first presented on PHP Unit at the PHP conference, there were 2 people in the audience. So that changed a lot. People now care about quality and testing and delivering good products. Can skip that. 3 years ago, I founded a company, the PHP consulting company, together with Arne and Stefan, who's not with us tonight, where we help PHP development teams around the world build better software with PHP and related technologies. For instance, like going to New York and work with a team like Etsy's for a week or 2 and help them get started with continuous integration, unit testing, quality assurance in the PHP project to help them avoid a lot of the hassles that you might run into if you try to figure out all these different pieces and technologies and tools and processes yourself. That's enough marketing. I don't really like marketing. So there are points in your life, in your career, or even in the industry that you're working in, where you think, hey, you've reached the top, everything is awesome. Well, the view here is awesome. This is not that far from here. It's a lot closer to here than it is from home. This is a photo that I took in Yosemite a while ago, like 2.5 years ago or so on vacation. So you are at that point in your career where you think, okay, everything is awesome. I have all the tools that I need to solve my problems. I can do good stuff. And then something happens, something changes, something that completely changes your view of the world. You suddenly realize, for instance, that the sun does not revolve around the Earth, that it's actually the other way around, that you're not at the center of the universe, that there is other things going on. And then you realize, hey, I'm not actually at the top, at the summit of my journey, but I'm only just starting. And yes, you already solved a lot of problems, but now you see that there are different problems that you haven't even thought of before. And one of those changing events in our industry was a while ago when the Agile Manifesto came out and people started talking about Agile, giving a name to some concepts that had been brewing up around the globe in different software development teams, where they realized that they want to change the way we develop software. And that's when that happened. And one of the major things there was in there was that we now have a value system that we want to adhere to when we develop software, that we value the people over the processes and so on. And on a technical level, all of this is really, ideally, really simple to implement. You can quickly develop new features. You test those features. You can quickly roll out these features to your users and make everyone happy. Looks like a gift wrapping factory. Somebody comes in with an idea, and at the end of the day, you have implemented that new feature and can ship it out. And ideally, that is. Which is a lot better than having to wait 18 months until you can ship something like in a non-agile waterfall kind of software development process. So it really cuts down the time it takes from somebody having an idea, somebody implementing that idea, writing down the idea in code, and then generate value for the company or for the users of your company, which may or may not be the same. And reducing the time it takes from having an idea and generating value from the idea, or even evaluating whether or not that idea is useful to the product, to the company, to the users, can save a lot of time and effort in the long run. And there are quite a few companies out there that do a lot of experiment-driven development these days, where business has an idea in the morning for a new feature. It can be as simple as moving an image that somebody clicks on from left to right and see whether or not that has an effect on conversion, or it can be something that all user experience or user experience books or usability books tell you will never work and is totally stupid, and you should not ever try implementing that concept in a website. Just trying it out and run an experiment with real users, just roll this feature out to 1% or so, and then see, hey, all of these books are wrong, and I actually roll this out because I have the hard data that at least for my product and my user base, all of these books are wrong, and the data shows me, hey, the concept works. Yeah, and software delivers no revenue until it is in the hand of the user, so cutting down the time it takes from idea over code to having it rolled out really helps a lot. And once we realized that this is the case, new coding patterns, new design patterns started to crop up. And as was the case in the early 90s when object-oriented programming became mainstream, developers around the world working in different projects had similar ideas, but gave these similar ideas different names. So it was, for a short period of time, really hard to communicate between different teams about the concepts that they came up with, until they realized, hey, it's the same idea, we just need to find a common name for it so we can have a common basis, a common vocabulary that we can use to discuss these kinds of problems. And for object-oriented programming, Erich Gamma and his co-authors did the job with the design patterns book, where they identified these 20, 30 design patterns and gave them common names, so developers had suddenly something like a common vocabulary that they can use, that they could use to discuss their problems. When these so-called latent code patterns started to come out, companies such as Yahoo, Flickr, Google, Twitter, Facebook all had similar ideas but gave them different names. Some called them feature bits, feature flags, feature buckets, whatever, which are all, at the end of it, just glorified names for being able to turn off or turn off a certain feature. And having a feature that you can turn on or turn off can be useful for various different things. So for instance, you can say, hey, I can do experiment-driven development. I can turn this on for a random amount of 1% of my user base and just see what happens if they like it or if they start complaining about it. Or you can just say, okay, I want this new feature only enabled for a very specific target audience and see if that helps me in that particular market. And there are some really famous examples about that when Twitter rolled out a new user interface, for instance. Some people already had that and were already complaining about it, and the complaining got really, really loud when to more people it was rolled out. That's feature flags. And a variant of that that's slightly different is dark launches. And that's something that Facebook did, for instance, when they rolled out the chat. And they used the dark launch approach to test performance aspects of this new feature. So they were at a point where they had the chat feature working, but they didn't know how the performance was. They did a lot of performance testing up front, with simulated users, but at some point they realized these simulated users probably don't behave like real users. So what they did was they rolled out the feature into production without the user interface for it, but had some JavaScript magic that was delivered to the clients that simulated chatting distributed from around the world, people chatting with their friends and so on. So they had a better way of simulating how real users would use this feature, and they used this data to measure whether or not it would make sense to roll out the feature now or wait or profile it in another way or enhance the performance. So that's a dark launch where you basically run out a feature, have it run in one way or another in production without making it visible that it's there. So if it breaks or if it stops working, nobody sees it, hopefully. So you don't get any bad press or blame or whatever. And there's another thing that you can do with these feature flags or feature bits or whatever you want to call them. And that's using them as what Twitter called it when they first used this or talked about it, the nuclear option. Like even once you decided, I want this feature, and the feature is rolled out to 100% of your user base, you keep the ability to turn the feature off. In case you are on a very high load, you can, feature by feature, reduce the functionality of the site gracefully without everything being out of service just because one feature is currently misbehaving with regard to performance. So that's nice. So if the concepts of feature flags and dark launches and nuclear options or whatever you want to call them sound nice, but you have no idea how to implement them in your application, that's usually an indicator that there's an architectural problem, that your architecture doesn't allow you to swap features in and out or to turn features on and off. There's a little bit of foundation that has to be there in the architecture to make this easy and to make it really quick to implement a new experiment, a new experiment that may or may not turn into a real feature. One last thing about that, and that's something that Booking.com does a lot and is very vocal about and in writing and in presentation that they do at conferences, is that they say no feature will be implemented in the perfect way or in the correct way until it has proven its worth. So what they do is they roll out a prototype implementation that may not be written in such a way that it could keep up with the scalability and performance requirements in case it would be rolled out to 100% of the user base. They just want to see whether it would work in theory. And then once it has proven its worth, they deactivate it, and a different team even re-implements the feature either from scratch or from just looking at the prototype and enabling it to handle the performance. But they don't waste any time on optimization before they know that it will pay off and will go into production.
Who was that?
Booking.com. So how does quality fit into this? So back in the olden days, when we were working with the waterfall model, quality happened at the very end. We had a lot of planning in the beginning, then a lot of development time, and then at the very end, at the end of an 18 months release cycle, for instance, you spent 2 or 3 months doing nothing but testing, and it was a different department, different people working on the quality, and they would feed back information to the engineers, and they would hopefully fix the bugs. So in today's agile software development, quality has to happen all the time. It's not something that you can do at the end. If you're talking about iterations of 2 weeks or 3 weeks, you cannot have a dedicated 1 week or 2 week of that to do the testing. So you need to get the people responsible for quality involved throughout the whole software development lifecycle. They have to work side by side with the engineers that actually implement the software or Sometimes it's even the same person. There's a great quote that I like from a really good book that I recently read, How Google Tests Software. So a lot of the stuff that is in this book has been on the Google testing blog for years, or has been communicated at the Google Test Automation Conference. But this is one of the key quotes from the book that they now released, where they put all of this information together. The only way a team can write quality software is when the entire team is responsible for quality. That helps with getting rid of the mentality that, hey, I'm just a software engineer, I just write the code and it's somebody else's job to make sure that this code works correctly in production. And if there's a bug in it, I cannot be bothered with that. That's somebody else's job to figure out that there is a bug, and then maybe I fix it. And that means that everyone, including management, developers, testers, everyone needs to be on board with quality assurance. Coming back to what we did earlier, the people back then responsible for quality looked at the software as a black box. They just tried to use it like a real user would use it, and they would find an issue and they would report it. I cannot do this, please fix that. But yes, this was not optimal in a way that they couldn't directly point to where in the code the problem might be hiding. But it allowed them to see the big picture, to see the software as a whole and test it as a whole. And today, it's harder to see the big picture because with unit testing, we are focused on small units of code that we're testing in isolation from all of the dependencies. We have static analysis tools that tell us on a line level or on a component level that a piece of code, a unit of code, a component is probably problematic, that it has a too high complexity or that it's prone to errors and whatnot. But it's really easy to lose sight of the big picture. Yeah, another quote from James. Quality is achieved by if you put development and testing into a blender and mix them until one is indistinguishable from the other. So you have to, while writing the code, for instance, have to keep in mind that you have to test this and that it has to fit within the big picture of the whole application. And yes, software metrics are really useful. Comes all back to Tom DeMarco saying that you cannot control something like quality if you cannot measure it. And software metrics are a really great tool, but so far they only work really well on the small level. They can tell us, hey, we have here a line of code that violates our coding standard. We have a line of code here that is prone to errors, and you might want to check that. Or we have a unit of code here that is really complex, and you better make sure that you have good code coverage for that on a unit test level. But it's really easy to lose sight of the big picture. And what I mean by the big picture is the architecture of the application. It's really nice when a developer implements a new feature, and according to our coding standard, that code that implements a new feature is correctly formatted, and a tool like PHP Code Sniffer or PHP Mess Detector in the PHP world that look at the code using static analysis do not find any problem with the code because it's not too complicated, it does not violate any state-of-the-art best practices and so on. But that piece of code could still be very problematic in the long term for my application because it violates the architectural vision that I originally had, the big picture for my application. I might be doing something completely bypassing some mechanisms of my framework that make it really hard to maintain that new feature in the future, and I might get into really bad trouble that way. Yep. So through the architectural vision, we have the big picture that we need to have in mind when we talk about our application, talk about quality aspects. And at the end of the day, it's the architect that lays the foundation for the quality in the project. And it's the job of the engineer to look at the same thing, at the same big picture from a different perspective and make sure that the code that he or she writes is not only in line with the rules laid down in rule sets for PHP Code Sniffer and PHP Mess Detector, but also along the lines of the architectural vision that it fits within the big picture. And that's what I meant earlier when I said that we may think that we reached the summit with regard to tools. Yes, we have really excellent tools that work on the lower level, but at least as far as I know, for PHP, I'm really sure that there is no such tool. But I've also looked for other programming languages, and I couldn't find anything that allows an architect, for instance, to really lay down the way that the architecture, that the big picture can be verified in an automated way, and that it can figure out using tools that you run into these kinds of problems that I just described. And that's summarized really great, I think, with a quote by Stefan Priebsch, who said recently in a discussion that we had, architecture and quality assurance are just two different ways on looking at the same task when building great software. And I think my 20 minutes are up. The slides will be here later. I will also give them to the organizers. So thank you. Any questions? Yes?
So speaking of feature toggles, one thing I've noticed is that you put these feature toggles in place, but with deadlines and everything, you don't necessarily test every permutation of which ones you might roll back. Can you talk about that challenge for a minute or two?
You don't necessarily have to test all different permutations while the experiments are running. So for instance, I've worked with teams that have 40, 50 different experiments running in development and have, and in the end, it's just 1 or 2 experiments that are live for any particular user. And even those permutations you do not really test that well, because you don't really have to. You have to do the main part of testing is done when it is merged into the main line, or when it stops being a feature branch, a feature bit or feature toggle, and it's turned on all the time by default.
Right. Well, let me follow up for a second if you don't mind. But yeah, you might have a suite of features get rolled in, and you might have the ability. Say you've got 4 new features in a release, and you've tested the heck out of all 4 enabled, and you're pretty sure your product works with 0 of them enabled, because that's what you've been doing in the previous release. Then you roll it out and you run into a problem with 1 or perhaps 2 of those features. I've definitely seen scenarios where somebody disables 1 or 2 of them and they don't exactly get the expected results because that hasn't been covered in the plans.
It's
I'm
really
not saying it's a reason not to do features.
No.
I'm just saying it's an input into testing.
It's a similar problem it's similar to a problem that arises when you use feature branches if you're in version control. Feature branches work really well if they're really short-lived. The longer a feature branch lives, the harder it will get to integrate it, not necessarily because the work that is done inside the feature branch is so complex or complicated, but a lot of stuff has changed in mainline, and maybe other features have been merged, and now you have to test them in combination. So ideally, you would roll out 1 feature at a time and not have a big release of multiple features. Most of these teams that I mentioned earlier, when they make a release, they roll out 1 feature. And that's because they are in a position where they can roll out new releases really quickly, and release is not a scary event that you're afraid of and that you put off for 18 months. And then, because that would really scare me then, wait 18 months, have 100 new features and roll them out and see that fail. So having it as small as possible are the thing that you roll out. Sometimes it's even just a couple of lines of code that get rolled out in a release.
Yeah, so could you comment a little bit on feature flags and version control and how those play together, complement, or?
So the question was, how do feature flags compare to doing feature branches in version control, for instance?
Right, and how they play together, or when to use one or the other approach.
There's no generic answer to that. It depends on what the team thinks feels best for what they're doing. I've worked with teams that say, we don't want to do the feature flags thing because we think that's too complicated for us or it doesn't fit the way that we want to work. We are happy to do this on the version control level. And they develop features isolated from each other in feature branches. And then at some point, at the end of the sprint, for instance, the release manager or release master looks at all the feature branches that are marked by the respective developers as finished and looks whether or not they meet the release criteria and then merges them into the main development branch and test it there. And then he looks at the second feature branch. Okay, that works in isolation. Let's try to integrate that, merge that. Okay, everything still works, including what I had before, what I had for the first new feature, and the second feature also. Then go step by step for all the features that you want to have in the release. Which is a lot.
So I guess those are definitely the different approaches.
Those are the different.
What have you seen as you've been talking to different companies? What's worked?
I've seen both, and what works better is what works best for the team. The team has to live with it, and that means that the team has to live this.
But is one team like working really late hours because their method doesn't work very good, and the other one?
No, it's just a matter of taste, like so many other things, because it also depends to a large degree on what kind of software you're building. So if you're building a website such as Etsy, for instance, and you are in a position where you can release a new feature a couple of times really quickly. Like if you look at Etsy's website, you can see blog posts where they talk about that they have somewhere between 40 and 60 releases per day, like which is code pushes. Sometimes it's just a single line of code that has been changed. Sometimes it's a new feature that a team has worked on for a week or two or a month, right? But multiple of those per day. Then it makes a lot of sense to work with feature flags, because a team can roll out their new feature and have tested to some degree in production using an experiment, for instance. And for the feature flags to work, it has to be in the mainline branch, because otherwise it would not be in production. But if you work on something where you have, for whatever reasons, because it's the rule of the company or whatever, fixed releases like every 4 weeks or every 2 weeks, which is still a lot more agile than having a release every 12 or 18 months, then you usually see this kind of thing happening on the version control level, where the features are developed independently from each other in separate feature branches, and at the end of the sprint, somebody in QA looks at each of these features individually and then merges them one by one into a development branch or integration branch and sees whether that works. And if all of them work fine, integrated with each other, that integration branch is merged into mainline and put into production.
You were talking earlier in your slide deck about having the right architectural underpinnings to support feature branches or feature flags.
Yep.
Have you noticed any common patterns that people are using to make that, like any sort of architectural patterns that make that more easy to implement or less?
Well, the main thing is that you don't have to implement a feature flag or whatever you want to call it by adding an if statement somewhere or a switch statement. Like if feature is on, then do this, else do the old thing. That is bad for very different reasons. It makes the code hard to read, makes it hard to see, okay, that feature is on, so then this happens, otherwise that happens. It's also something that tools like PHP Mess Detector will point to, because it increases cyclomatic complexity. You add new branching points, so that's something that you want to avoid. So ideally, you are in a position where you can implement a feature flag using object-oriented principles, that you extend a class and have a variation of that class's functionality using OOP concepts. And then at a central place in your factory, for instance, or in a dependency injection container, or wherever you create all your objects, have the flag, like if this feature is active, I create this object. If that feature is not active, I create another object. And then the code itself does not need to care about all these ifs or switches or whatever. That reduces complexity and makes the code readable and maintainable.
It's easy to switch off.
And it's easy to switch off.
A new class, and it's gone.
Yep.
The funny thing is, well, I can pretty much skip on the introduction part, I guess, because I'm obviously one of the guys from this company as well. And well, my name is Arne Blankerts. I don't have a personal slide on this one, just because I feel I save on time. I'm the security paranoid in our company and the infrastructure guy, so well, probably that fits together somehow. But anyhow, it's interesting, like quite a few things that he said about the quality and how architecture comes in play. It's pretty much the same thing for security. And the most important part, at least to me, is that quite some people keep forgetting where security comes actually into action when you do stuff. And it's interesting to realize that if you write software, no matter what type of software you're creating, you're probably running it in whatever kind of infrastructure. If it's a website, it's probably going to run on a server. If you create mobile applications, it's going to be run on a phone. But if you cannot trust the environment you're in, then there's hardly anything you can do to actually make things really secure. So it's always the weakest link, which is the basic question. And quite interesting is that quite some companies figure like, okay, we need to know what other companies are doing so we can judge how good or bad we are in this particular comparison. So let me check out the name again because I keep forgetting it. Coverty? That's
Coverity.
Coverity? Okay, yeah. Okay, that's the way to pronounce it probably. That's actually supposed to be quite close to here, like 5 minutes or so, somewhere down.
1 block away.
They asked Forrester to conduct a study on what the current status on web security is. And the interesting and scary thing is that, well, they got quite interesting results. And one of the main things they got back was like, hey, we need tools, and we don't have tools. So that's why we actually are really bad in security. So the really important part is 71% of the people that replied figured like, okay, actually, we don't have any knowledge on how to use tools, even if they would exist. And without the tools, we are not able to deliver any secure type of software. So that's why we have security issues. This is an interesting idea. I don't necessarily agree on that, but we're going to go to that in a bit. Another interesting fact from this study is that they have configuration issues. What they came up is like, okay, we have like moved from our own systems and own hosted servers into the cloud, so we do not need any administrators anymore, right? I mean, it's cloud, you click on every interface and the system magically appears and then there's the service and you can use it. How cool. I mean, admins, we can fire everybody. It's like cool, layoffs, we don't need developers at some point, maybe because software just auto-generated, I don't know. But at least for the administrative part, that's cool, we can skip on that. Well, turned out that was a big issue, because 66% of those companies that had 10 or more incidents in the past reported they had issues because they still use default accounts and default passwords. So if you set up a MySQL server, for example, on a machine of your liking, the default user is the root without a password. Why bother changing? I mean, you're the only one using it, right? So just keep on with the default. Still, the scary combination is that like 66% of people with 10 or more issues. I mean, you should figure that by the first time you got hacked by this, you get a kind of learn from that. But obviously, no. Another interesting fact that comes from that, in general, they have general security misconfigurations, like having open SSH ports or just have whatever MySQL server being publicly available. That also might actually be a logical problem at some point. If you have a developer not working in your office, but somewhere on the road, or need whatever kind of freelance people being able to access your systems, they might actually set up their own systems for testing purposes. Like we had a nice audit like a couple of years ago at a Swiss company in that case. That is really, really paranoid internal systems. They host everything in their own data center because they don't trust any ISP for whatever reason. And they had like a freelance developer doing one of the main register, whatever kind of functionality for their website. That was a new feature. And that stuff was stored in a MySQL database. So the developer was working with a locally installed MySQL server on his machine at home. And then at some point, everything works fine. All tests are green. Everything is perfect. Pushed the code into the office. They checked it. Yep, looks fine. OK, deployed it. And everything works perfectly. And then we were there to make an audit. And we were allowed to do an audit with scanning the network infrastructure. And we figured, like, every time we hit this particular page, we see network traffic leaving the local network. What the hell is happening? Turned out that the person writing the code did, for whatever reason, hard code the MySQL login to his personal machine. So everything was safe inside the network, just everything could get out anyway. So instead of hacking into the secured environment, which was really hard to do because they had like lots of levels of firewalls and even application level firewalling in there, checking things twice at least, well, skip that. We just hack the original system where the MySQL database is like with an open port because it has to communicate to the outside world. So the infrastructure was a configuration problem. The funny thing is they would have noticed that if they would have monitored their own network infrastructure, and if they would have a firewall rule saying, OK, this machine is our web server, and it's not supposed to communicate with any other box except for our local MySQL server. So if there's a firewall rule in between, that's an easy setup. I mean, that's what we have admins for. Oh, no, wait, we fired them, right? OK, well, maybe that's a problem. But speaking of databases, that's also something that the Forrester research showed. Like, almost 40% of the people having issues have the standard SQL injection errors. And especially the Java people all the time say, like, no, we don't have that problem. We have prepared statements. Funny thing is, prepared statements don't necessarily solve all the problems. To begin with, prepared statements were meant as a performance tool, not a security tool. Because it obviously makes sense for a database if you have a long-standing connection and you know how going to do the same query type all over again, but only have like one variable that's actually changing all the time. You can use all the static part and have the database prepare the result set for the static part already, so you don't have to look into millions of records, but maybe just like a couple of hundreds or thousands. So that's going to save a lot of time when trying to answer to a query. So that's where prepared statements make a lot of sense. The nice side effect is that if you're going to prepare a statement, that you can say, OK, this is this field, and I'm going to supply a value for this particular field for the upcoming query. So the database engine already knows, OK, this is supposed to be a string, or this is supposed to be an integer, or whatever. So you can abuse this functionality for security reasons, so the database API can do all the escaping for you. Funny thing, though, is that there are quite a few things that you cannot prepare. If you say, OK, I'm going to sort my stuff, I have to actually have an order by or whatever kind of mechanism to rearrange the order. So I'm going to supply that as a field name. But the field name is nothing the database can prepare on. So prepared queries don't work here. Same thing is if you say, OK, I'm going to change the number of fields for whatever selection. So it's going to be a list of fields. And you can say, OK, just skip on this particular item in the list. Then you're going to change the field names that you're going to select. That's also not preparable. So there are quite a few scenarios where no matter what programming language you use, prepared statements are not going to help you. And that obviously results in quite a big bunch of SQL injection errors on various websites. Even big banking sites have that issue. So it's quite funny that people believe they are safe just because somebody told them at some point that if you use the prepared statement mechanism, it's going to help you for everything. So actually, it's not. The most scary thing, at least to me, is that time to market is the issue, obviously, because that we are here on continuous delivery, right? And we want to have features out all the time as soon as possible. And 41% of the people replying to the study said that, OK, we have security issues because we have the time to market issue coming to us. So we don't have time to test this stuff properly. We don't have time to think about security. We just have to get the feature live. Well, this kind of mentality costs obviously quite some money, because every time you have a security issue, sooner or later, it's going to be expensive. And quite a bunch of people say, OK, actually, we have a lot of security issues in our application or in any kind of application that we used, which is web-based or web-facing. And I think 51% is quite a big amount. 18% of the people replying said they lost over $500,000 worth on either damage because they actually had shipped out stuff that they were not supposed to, or they had to recover any kind of lost data and then had to redo things, or had to maintain any kind of lawsuit just to make sure that nobody is actually going to be too pissed about what happened. That's quite a lot of money. And if you think about what you spend in this kind of thing, I mean, 18% is obviously not the majority yet, but still quite some people losing money on this I would rather spend that money on development time and save quite a bunch in the long run, I guess. It gets even worse, at least to me. I mean, how can you not know that you had a security breach and you don't know how expensive it was?
Because you don't want your boss to know.
Yeah, maybe that's a good reason. So, to me, that's a really big fail. The most important lesson to learn from this research is that if you read it, I mean, they have like lots of pages in there describing how they did all this stuff and what people replied in detail. Just picked out some numbers from it. The study is online. If you go to the, what's the name of the company? I keep forgetting it. Coverity, thank you. Website, you can just click on the first research register, and then you can download a PDF for it. So it's quite easy to find. They don't necessarily know where to go from here. I mean, the majority of companies replying were like, OK, this is our situation, and we have no idea what to do. So where do we move to? And what do we do? Well, remember, security stuff is the weakest link, right? So what can we do to make this link actually be more solid, more secure? And what they keep doing, at least according to the study, is they do code reviews. That means that somebody's looking at the code and, well, looks good to me. We can ship it. Actually, that's not necessarily bad to begin with. I mean, looking at code obviously helps to change the security to some extent because it's going to change the quality because more people looking at it are more likely to find any type of flaw, no matter if it's security related or general code related. But obviously, it's not enough. And especially for PHP, there's like static code analysis that should be working for any other language as well. You can come up with guidelines saying, OK, we're not going to use this type of functionality, or we're not going to call this function, or going to use this method of accessing the database, or whatever kind of rules the team can come up with. And you can have tools to verify this. This is really simple. If you write PHP stuff, there's, for example, a PHP code sniffer as one of the tools. You can say, OK, if we have this function call in our code base, we are going to not allow this to continue on in the deployment process. Simply stop this. It's not allowed. It's not just about formatting code. That's for teams. Obviously, it's important as well. But from the security perspective, it's quite easy to say, OK, we're going to reduce the functionality we have available in our programming language and reduce ourselves to defined APIs. And if you say, OK, I'm going to have my coding guidelines say, OK, we're not going to access, especially for PHP, the request variables directly, but we have a wrapper for it, and with a defined API, then quite a few of the security problems you have by default actually don't even appear. Another important thing to do is actually the same thing as for quality is actually stress testing it. Just throw stuff at it and see what happens. There was a nice example that some guy gave at a presentation I attended a couple of years ago. That if you have a cat, take a cat, throw it on the keyboard, see whatever it's going to type. This is definitely going to be so crappy that nobody is going to expect this data. If your application survives it, it's good. So stress testing with cats on the keyboard probably helps because they do things you never imagined they would be doing. Another important thing to do is to see by this, OK, what happens if something is not in the order you expected it to happen. The best thing is if you run a web store or web shop software, you have multiple steps on checkout, right? I mean, check your basket, supply your delivery address, give out whatever kind of payment method, and so on. That's multiple steps. So what happens if you call the last step before you actually had the second or first step even? I mean, it's HTTP usually. So you have a, how do I place that into order? You have no necessarily state in the request itself. I mean, the application probably requires you to go step by step to make sense. But since it's an HTTP request, each individual request is, well, is an individual request. And there's no reason for an attacker to not mess around with that order. Once you had all the steps, you know all the URLs and all the parameters you're going to supply. But if you're not necessarily considering the fact that it might be called in a completely unexpected order, well, then the application might actually run into quite interesting issues. And we had a nice, interesting example with that as a shop, where you had a checkout step. One is obviously, OK, this is your shopping cart. Buy this stuff. Yes, OK. How do you want to pay? Then where do you want to have it shipped to? And the last page, where do you want to have it shipped to, assumed like because you reached here, obviously everything was paid already. So perfect, we just skip on paying. So because we just accept the card and then directly go to step 3 and get everything shipped. And they just realized like a couple of months later, in testing luckily, that actually you could just skip on paying because you could just jump over to one page further on. And that's just by changing one step in the parameter in the URL, going from step 2 to step 3, and there you were. So understanding that having different URLs, meaning independent requests, and having the order is quite important. And again, the same thing happens. We need the matching architecture. And this is our standard picture for architecture, obviously. So it's quite obvious if you want to make secure software, and you don't have the time to add it later on, which makes complete sense, because adding security at the later level makes it quite hard. But if you design your software properly, and having number one thing in the architecture is separation of concerns. If you make sure that, for example, on the view layer, if you want to output stuff, you don't have an option to query the database anymore. Well, nobody is going to be able to inject anything at that particular stage anymore. If you make sure that by the time you want to output HTML, you don't have access to an unescaped way of user input, well, there it goes. No cross-site scripting security bugs anymore. It's the default API that you provide for the people writing the views. So it's actually quite easy to avoid the majority of the security problems those companies were facing. I mean, it obviously requires a bit of knowledge if you want to create or update the infrastructure according to whatever kind of technical requirements you might have and keep it maintained in a secure way. But still, this is what the admins are for. But you have to communicate with the admins, saying, OK, see, I need the database installed here, and I need a database user that allows me to read from this particular table. Some other administrative task is going to put into the data here, because we have a search engine. The website doing the search stuff does not necessarily have to write anything, so I don't need a database user with write access. This is a simple configuration issue, but it's communicating with the administrative team to do that in a proper way. Same thing for the views, as I already mentioned. If you have an output based on user input, might be a form, might be some kind of feedback information, blog post, whatever kind of thing that people write stuff, well, you have a template, right? I mean, and the cool thing is saying, OK, I need HTML output. That assume that this would be HTML for whatever properties. Saying I'm going to create links based on user data. Well, then there's a different API for it. It's easy to provide different APIs for everybody to use on the view layer and not allow access to the original user input anymore. If you don't have any means of accessing the original, potentially dangerous values, well, there goes your security problems, because you have one single spot where the responsibility makes perfect sense. OK, we're escaping the user output or user input for HTML, for JavaScript, for whatever kind of thing you want to do. Same thing if you want to communicate with the database. If you have a dedicated layer for that, it's easy. As soon as you mingle everything into one box and have a complete bizarre way of handling spaghetti-type code, then obviously it's going to be quite hard to make everything secure, because you don't know where in the code you actually are. And the most scary thing I saw like a couple of years ago in a code review was the magic make everything secure function. It was actually called like that, make everything secure. And what they did do was like they run HTML entities, as in change everything that looks like HTML into like entities so that it's safe for this part. Then did run add slashes on it for whatever measure, so they can use it and in a database query. Everything messing it up. So in the end, the data was useless because you couldn't use it for anything anymore. And then they called us to like, we have a problem here. Well, that obviously worked to some extent. Another important issue, if you have any type of problem on your website, the worst thing you can do is tell the user all the details. And it's really interesting that the majority of websites still have that issue that if you click on a link that's broken, you get like, OK, hey, you got this stack trace, and this is the parameters we have, and this is our environment, and you actually, you're on this particular server, and there's subnet of this IP address range, and our database version, blah, blah, blah. And why? Nobody needs to know. Make your server shut up. That includes all the headers. We had a nice customer who figured out, actually, we need debug information, so we're going to send the debug output in headers, so that's invisible. Nobody's going to see it, right? Except everybody who's sniffing it or looking at the header output for good measure when doing an audit. So it was interesting to see all the debug layer. OK, we're doing this, we're doing this. There are interesting extensions, even to PHP, that send out everything by headers. you don't want this to be publicly available. So if you have a security problem or any other problem in your infrastructure, try to either disable the feature in case you have the ability to say that, OK, we're going to skip on this feature because it failed like a bunch of times, or by simply saying, OK, sorry, we are out of service with this one. The administrative team or developer has already been notified with all the details. Obviously, you need all that information, but you don't show it to a user. OK, I have like a quick minute left. There's a nice project, the Open Web Application Security Project. That's an open source kind of group that maintains a list of security problems. And the funny thing is, if you check the list, that's a top 10 list from 2010. They are starting to work on the next edition that's updated every second year or every third year, depending on the need they figure about it. Those are the security problems that are most common in web applications. And if you see, like, some of the things are actually quite simple to realize. If you say, like, OK, the first one, just the, even though it's on place 10, it means it's quite common anyhow, is redirecting. Quite many people have, like, websites where they link to outside world. And since they don't rely on JavaScript-based tracking, they have an exit kind of page where the link they're going to send somebody to is passed in as a parameter. Well, that works technically, but has a side effect that if you modify that particular parameter, you can redirect a person to every location you want, which may not necessarily be a problem for your site on a technical level, but might be on a psychological level, because people assume by the fact that you're redirecting it through your site and they trust you, that actually the trust has been abused. This is a non-technical issue, but still something that happens quite often. Just the other sides, cross-site request forgery, standard problem as well. And if you look at the problems, and the website, OWASP.org, has also a list of what you should do to avoid those problems. And that's just like a tiny few steps all the time. And if you check all the things and consider implementing it in your architecture, in your software on the design level, it's easy to implement. It's not much work. It's nothing you actually have to spend much time on. So the sane argument they keep telling, like, remember, it's 41% saying we have a time to market issue. We cannot spend time on security. It's actually wrong, because all the problems that were mentioned are actually all easily fixable, and they don't affect the time to market at all. You just have to make sure that you think about it before you actually start implementing it. And then if you have the basic infrastructure right, I mean, have the admin set up everything correctly, that's easy. And then the weakest link finally becomes the person using it. And your software is safe, which is the main part. So we managed in succeeding to create a sane infrastructure and a sane application. And that can be done on whatever amount of deployments you want to do, because the infrastructure itself and the way the software is being designed is secure to begin with. Well, thank you. Any questions on this? Yes, sure.
So you said one of the main things is not providing the users all that information when you make a mistake. So how do you, is this something that you just have like as a turned off at production level, or like how do you still manage to get all the debug information you need during test?
Well, it depends on how you want to output them. I mean, yes, one would be a configuration option. Another would be just to have a separate way of sending it. If you store it on a socket level, for example, there are quite some systems that actually send out stuff to monitoring sites on a, well, make a different TCP connection or whatever. Just have a separate way of sending out information. I even created an extension to, or not extension, just some PHP code. I don't know what programming language you're working on, that uses a socket connection to send out debugging information. So it's a completely isolated process. So if you're on a normal end user level, you don't have the way because you don't even see the output. Yes.
So, like I totally feel you when you're saying you have to sort of architect with security in mind, right, in order to have a secure system. But in a way, it almost seems like a waterfront strategy, right? So, in Agile, right, we have tools, unit testing and all this, that we can sort of ensure the quality as we go. What tools are there for security that we can sort of ensure it as we go?
Well, it depends a bit on what you want to actually check on. The funny thing is that if you write proper unit tests, you're also not going to write for the, well, sane path, as in the happy path, but you're going to try what happens if you supply invalid information. And if you know, like, OK, I'm going to test my database abstraction, for example, you're going to supply values that you know that would blow up the SQL query in case there would be an SQL injection error. So you basically have that as a side effect. That's why I said that quality and security, that actually is kind of the same to some extent. The funny thing is we realized that when we started our company that we were coming from different aspects, different views on things, but we actually look on the same thing all the time, just with a different idea why we want to have it like this. And the separation of concerns that the object orientation and architecture people keep preaching about, that's exactly the same that helps you with the security. If you know like this particular piece of code doesn't have to deal with this information or this level of information, well, that's easy. Then you don't have to test for the security at that particular point either. So it's only the output layer. If you create whatever rendering API, then that's easy because you know, okay, I have to throw whatever kind of bad data at it and see what happens. And if it managed to get out, then I know I have to change my code. But that's also the security part. Then there's like various tools that actually just scan for the standard problems like cross-site scripting and stuff like that by trying to mess out with parameters. There's like the puzzling that I mentioned, like calling stuff in unexpected orders. There's tools scanning your website and then just randomly calling the URLs again and see what happens. So that's like black box testing in a way, or penetration testing. That's something you can obviously do. And it's, of course, monitoring is the main thing to do. If you have an infrastructure in production, it's vital to know how these things actually perform and what's normal for the website to happen. Like, okay, this is the standard load on our CPU. And if you see like, hey, for whatever reason, the CPU load changes in whatever way, I may be dropping down or maybe going up, that's something you should be alert of. And the same thing for like traffic, if you, as I mentioned with the example with the MySQL server being on the outside. If you have your infrastructure set up, the firewall would actually notice like somebody is trying to connect to this, I don't know, whatever machine somewhere. I want to have an alert for this because obviously something is going wrong. That might be simply a configuration issue because obviously the firewall might have not been updated to allow this, but still it's an alert because the firewall figures like, hey, this is against my rules. Or it might be like somebody hacked the machine and it's actually somebody trying to download new code to execute on the machine or whatever. You don't necessarily know. So it's a lot of monitoring involved in that as well.
Would you recommend doing some of this pen testing like during your continuous integration cycles?
It definitely helps, but pen testing is nice, but it's not necessarily the most important part. The clean architecture and having all the standard problems covered is the main thing. Penetration testing is an automated way of trying to poke here and there, but if you are the developer, you know where to actually look and what's potentially dangerous. We had a presentation with some other security guy working for a company that probably, I think they don't exist anymore. It's one of the startups that didn't make it. They realized that they had a security issue that they didn't even notice by any type of testing or monitoring, that you could just copy one ID to another system and then see stuff that you were not supposed to be seeing. They figured that out while developing, because they were like, I don't get why this doesn't work. Can you have a look at it? And then he did send out the link to the other guy, and then he continued looking at it and like at some point realized, actually, why was I allowed to see this? Because I'm logged in as somebody completely different. I shouldn't be seeing this. So they by accident kind of found it. And there was no pen testing tool because you couldn't come up with the ID to actually start with that. Sure. So penetration testing is like, well, you can see the low-hanging fruit basically with that. So it's up to you if you define the use case. It depends on how your company works. But if you are based on user stories, for example, you also know, okay, this is what I want to do, and this is what I don't want to happen in case I can do this. So you can write your own kind of, well, end-to-end test or edge test or whatever to try to resolve it and see if you actually succeed in getting it. So it's pretty much the same with quality, just try to be non-happy path, basically. See if it fails as it's supposed to. And the funny thing is, the problems that were mentioned, even in the research, there's hardly any real issue like, okay, I could see this without being actually originally expected to see this. It's all the standard low-hanging fruit problems all the time because they don't have the time to do things properly. Even though if the architecture would have been correct to begin with, they wouldn't even have to deal with it. Right. I'm not saying that everybody has that issue, but still it was interesting to me to realize that whatever, if you see this, at least for me, when I was reading this PDF with the results from the research, it's like, but you shouldn't have that problem to begin with. Why do you even, they're even losing money with it. I mean, seriously, just fix your code. It's on a very slow level that you actually, or very small level that you actually have to change stuff. Nobody expects you to rewrite everything from scratch. It's just like if your architecture doesn't allow you to have a separation of concerns, you have a serious issue in whatever world you're living in. What also helps is to actually just draw up the workflow. See like, okay, this is the request and this is what's supposed to happen. And then realize, okay, at this particular point, I need to have ACL checks or whatever coming into play. But this is hard to automate. You actually have to understand what the system is supposed to be doing. Yeah. Well, okay, well, thanks again.
Thank you.